Another projectile motion problem. Hopefully they're becoming, I don't know if I want to say routine yet, but you're getting the hang of how to do these. The method's going to be, sorry about that, read through the problem, sketch it, pick out the 3 numbers in the question mark. So I don't know if I'm going to be able to do a good drawing of this one, but we've got a stream of water. That's terrible. Pretend that's a water droplet. Water behaves like a projectile. It's shot horizontally at 6. It hits the ground 2.4 meters away. So it follows its nice parabola, crashes into the ground. This distance is 2.4 meters. How high was the water shot from? So the question really is asking, how far does it fall, or what's this distance? We used the same method, but it led to sort of a different, basically the question's different this time. Since we're asked for how high, that's a vertical distance, we're going to start with the horizontal. It's kind of nice to start with the horizontal because the horizontal, since it's just constant velocity motion, it's actually a little bit simpler. Horizontally, we know that the water is traveling across the ground at a speed of 6 meters per second, and we know it traveled a distance of 2.4 meters. We're always, in our projectile motion solving, we're always finding time and then using the time. Horizontally, we just have one equation. V equals d over t. If we flip-flop things around to get t all by itself, t is d over v. Or you could plug in numbers and then rearrange, whatever you're more comfortable with. The d was given as 2.4 meters. The v was given as 6. When you do the math on that, it's a nice clean number. You're going to get 0.4 seconds. Well, now that we've got the time, we're going to use that time in the other component to finish the question. In this case, we're going to use it in the vertical. For this particular one, again, if we think about perspective, imagine we just drop something from rest. How far would it fall in 0.4 seconds? That's what it would look like to someone standing way in front of this as they watch the water fly through the air. We don't know how far it fell. We know that it started from rest. Since we shot it horizontally for that first split second, it hasn't really fallen. We know that we know gravity's pulling it down at 9.8. And we just figured out that the time is 0.4 seconds. Kind of the same thing over and over again here at the vertical. I don't care about V2, so I'm going to use that same 1/2 AT squared equation. Since the V1 is 0, this whole term disappears again, so I've got 1/2 of 9.8 of 0.4 all squared. You can get your calculator out. You can get your calculator out and check that, but when I clean that up, I get, within some rounding, 0.78 meters. So if we go back and answer our question, how high was the water shot from? The water was shot from 0.78 meters.